Okay, I'm here with Miguel Duarte, Money Button developer who has programmed basically all of Paymail. I don't know if I mean, certainly probably about 99% of it. Um, so Miguel, I thought it would be cool if basically, so I've created a sort of a series of videos to get up to this point that just kind of explain Paymail. But you know the code obviously better than anyone. So I thought it would be cool basically if you could explain the source code for Paymail in a way that is intended for basically anyone out there that actually either just wants to understand what it is, or if they're actually programming a Bitcoin wallet. And I want to say one other comment though is that one of the problems that we're solving is with Money Button is to make it as easy as possible for people to do Bitcoin stuff. So you shouldn't actually have to program Paymail yourself. You can just use Money Button. But if you are programming a wallet, such as you own another, you're part of another wallet company or something like that, we are providing this source code open source under the OpenBSV license for anyone to use. So do you want to, what are your thoughts, Miguel? And any comments or anything?
Yes. Well, actually, I'm sure that our implementation of payment was the first one, and it's one of the more used. Like I know that there are other wallets using our implementation, which is kind of cool. Also, I know that there are other implementations. I saw people using Java, like a Java implementation. Our implementation it's in JavaScript. It's pure JavaScript because that's what we use, and also we believe that it's a really well-known language. So it was a good language to start. Basically, it's probably lots of apps can use it basically. And well, also like the idea was follow at least how JavaScript developers used to work. So that's the style that we use. We use all super standard libraries and the build process is super standard. So like always the idea was having as much compatibility as we could, basically. So, well, I don't know, we can start. We can like go.
Yeah, well, here. Why don't we I'll phrase it as another couple of questions. And I think you're ready to show the source code, but let me just sort of ask a couple of questions. So
yes,
first of all, we actually have two different Paymail libraries. One of them is called, I think it's called Paymail Client, and the other one is called Express-paymail. So you want to maybe just briefly explain before looking at the code, like what are these libraries and why do we have two of them?
Yes, makes sense. Well, Paymail is a protocol basically that describes interaction between two parties. Usually, like the most simple case would be someone that is paying to some other person, and those two parties have like different roles. In general, like if we are going to make like a metaphor using regular web development, is the same thing as client and server. You have someone that wants to pay to some other person. Usually the one that has to pay is the client in this case, and the other person that is going to receive the money is usually the server for how payment works. And both of them have like different roles in the interaction. So we have one library that is the one that probably people is going to use if they want to implement a wallet. That is called Express-paymail. Express-paymail is just an Express.js router that implements all the protocol for you. And the only things that you have to specify are, for example, are the stuff related to Europe. For example, if you have an HD wallet, for example, you have some way to get an address for a user. That is not solved in Express-paymail. But if you tell Express-paymail how to get an address, Express-paymail is going to manage all the protocol for you. Like it's going to create a standard response, and it's going to reject queries that doesn't follow the standard and all the stuff. The only thing that you need to provide are the stuff related to Europe. All the payment protocol is handled by Express-payment. Payment client, on the other hand, is how to interact with a server that implements the payment protocol. So I can see reasons to use payment client, even if you are not a wallet. Like you might want to create a script that for some reason, I don't know, needs a public key of someone to sign something, for example, and you can do that pretty easily with payment client. So those things are like separate roles, and the code is really different, and that's why we decided to make two different libraries.
Okay, all right, makes sense to me. I hope that makes sense to the audience. So maybe if you want to, do you want to show the source code? I mean, you go into
Yes,
that?
completely. Let's start with, well, I don't know, I have both of them open here. Something that is kind of nice in both README files, there is like a small example of how to use both of them. This is Express-paymail. As I mentioned, what you have to do is actually create like the idea for using it is create an Express app. It uses Express.js.
Miguel, are you trying to show the source code right now? Because I actually see your face. I actually don't see the source code.
Makes sense. Let me share the screen, which I don't know exactly how to do here. Share desktop, share screen. Can you see my screen now?
Yes. Okay, I do see it. Yes.
Great. That makes much more sense. Well, so what I was saying, in the both has like a minimal example in the README file. The idea for Express-paymail is basically you need to use Express.js. And the idea is that you need to create an app and use this special router. In order to create the router, it exposes this function called build router, where you need to specify the base URL of your app and a configuration option. Usually the minimum things that you need to provide are this function get identity key and get payment destination. Try and explain in other videos what is this identity key. This key is like a public key for a user. It's not meant to receive money. It's meant to do other stuff to identify the user. And get payment destination, what is what you use to actually send money. So this handler receives, for example, this name and domain are the two parts of a paymail, like what goes before and after the @ symbol. This body attribute is whatever the user sent on the request to get the payment destination. And this helpers method is a convenient method because usually what you have is something like an address. But in the payment protocol, we don't speak about addresses. We speak about outputs because it's more convenient for wallets. So it provides this useful helper. So to, for example, transform an address into an output that in order to work with the standard, basically.
Yeah.
This is the idea for all the configuration. Usually you have like a handler for every capability, and you receive an appropriate set of attributes, and you can build a response with that. For example, forget the entity key. The only things that you need are the name and the domain. And this, again, this match with the specification. Let me open DSP alias.org. If we go to the public key infrastructure capability, we can see that the only attribute here is what is called alias and domain. And that's the same thing that you get here.
Yeah.
And another nice thing about the code is that it has a lot of test coverage. You can see that there is test for everything. So if, for example, you want to see how this identity key works, you can go for the identity router test, and there is a ton of tests for everything. It has, I didn't measure it, but I'm sure that it's close to 100% of test coverage. Yes, sorry?
Yeah, no, just saying, okay. I have a few comments. Do you want to go back and look at the
Yes.
README file there? So I just want to comment because I can, I'll sort of explain things from a slightly different perspective and maybe phrase some of this as a sort of a question for you. So,
Yes.
so first of all, in the BSV alias spec, so I did an overview of the spec, and it's designed to be extensible, and so that we have the freedom to add in more capabilities over time. And the interesting thing is, so the capabilities kind of require, so there's only so much of it that can actually go inside the source code itself. And we have to allow the developer to plug it into their own source code. So what we're actually really seeing here is you're showing how the developer passes in the proprietary parts into the protocol so that it can do stuff that's for that application. So
Exactly.
in this case, like basically in order for the paymail server to return a public key, the developer must attach the paymail code to some kind of internal code that actually gets and returns the public key. And so that's what you're showing here. And then that's what these are. These are like you're configuring these extensions. So there's like an extensions for get identity key, there's extension for get payment destination, extension for verify public key owner, and you're plugging in the proprietary part of that, and you're showing how to do that, right? Correct?
Exactly. Also, the idea is make it as human readable as possible. If we go to verify public key owner spec, this is like here. If you see the BRFC is this random looking number, but I don't know, this doesn't tell anything to the developer. That's why we use like the human real name for stuff.
Yes.
And then the library transforms that name for you and creates all what is needed to actually interact using the BRFC's files. So format, sorry.
Yep.
So yes, something else, something that probably wasn't clear enough, or some comment.
No. I think no. I'm just wanted to clarify that just because I had a way to explain it. I think that might help people understand what it is that we're looking at here. I do have another comment. So I mean, this is based on Express. I'm not sure if that's strictly a requirement. Like it might work with other servers, but of course it makes a lot of sense that it's based on Express, just because Express is by far the most popular Node.js server. So it's like, because it's almost everyone uses Express, it makes a lot of sense for us to make a Express plugin basically that you use. So yeah.
I know that there is some other Node server that is not common, but that this is the second more used, that is called something with K, Koala or something like that.
Yeah.
It might work with that. I didn't try it, but it's true that it might work with something else.
Yeah.
But as you say, like Express is the facto implementation for a server in Node. Like it's almost all the community use that.
Yeah.
So well, let's go a little bit like a few interesting things, like how there is like every time that you decide to implement a new capability in your server, you actually need like two things. First of all, of course, actually managing the capability. For example, if you are going to say that your API can verify the owner of a public key, you actually need an endpoint that does that, right? So that's the first thing that the Express-paymail does. It creates a handler where it first handles all the protocol stuff. Then it calls this handler where, as Ryan said, you can put your proprietary code there, basically. And then it uses your response to follow the protocol and give the proper response. So that's the first part. And the other thing is create a .well-known/BSV alias file that actually reflects your API. All that flow is made in this file, index.js, is where basically checks all the capabilities. It checks if you are using the capabilities that Express-paymail knows, and it's like it updates this capability subject according to your configuration, and at the end, it basically creates a router with all the stuff. And again, I don't want to go to the detail, but it's important to know that here is like where the magic is happening, basically. And again, for these things, there is test. And if you want to see like the detail of how it does everything, you can actually see a working test of what it's creating and how the different configurations affects the well-known file that creates and the router that creates and everything basically.
Yeah. So that's a good thought there, is just that if developers have questions, because it has such good test coverage, you can actually learn a lot just by reading the tests to see what the behavior is supposed to be. It's actually very explanatory. So it's a good thing for developers to do if they want to.
Completely. There is one probably not usual, like I said that I try to use all the standards things, as like use all the standard practices. There is probably one that is not really standard in Node, that is these dev things. This is because I spend a lot of time programming in Ruby, and the thing that I miss the most about Ruby is the testing framework. The testing framework Ruby has a really useful thing called let, where you can define lazy variables for tests. And it's extremely useful, and it lets you create really, really easy to understand tests. So I found a library called BDD lazy var, which is an implementation for that, but in Node. And once you understand that this is just define a lazy variable, and this, like, if I look, for example, get here, for example, I consuming that variable, that's the only unusual thing that defines lazy variables, and it consumes lazy variables. That's it.
Okay. Yeah.
Great. So let's go into the indexing. And basically, if you see what it does, it basically calls all this build the entity router, build get payment destination router, build verify pub key router, and it's always the same thing. If you are using the configuration for that router, it's going to use the router actually and add the capability. And we look into these functions, it does exactly that. It basically has a callback that is only going to call the Express-paymail, the size that it has to use this router, and the configuration that you use to create the router. And this is really easy. It checks if the identity key callback is the final, and if it's the final, it creates a router. It does all that is needed, and call the callback. And that's like the same dynamic for all the other capabilities, basically.
Okay, so you can if they're not present, then it's a way of disabling that capability.
Exactly. And well, there is a few default values, like if you want to use cores, the default is true, because in general people want to use cores. The cores will be cross origin request. I don't remember what the S is, but it's easy to Google. What you want to do if you want some special configuration for cores, you can actually specify that. And if you want some special error handler, you can actually specify that. So there is like a few defaults that you can easily change by specifying in your configuration.
Mm-hmm.
The error handler is a standard error express error handler, like a middleware to handle errors, nothing special. Well, that's basically it for Express-paymail. It's not a big library at all, but it's easy to extend. There is a few things that like we plan to add in the middle future, probably. Of course, more capabilities, because people is working in good stuff and we want to cover them. Another thing is improve how the cache works. We are going to speak a little bit more with the client, but there is a few cache headers that we plan to add and implement to send the right cache headers and allow people to have a better cache of the stuff.
Yeah.
And something that I would like to do, but I don't know when, is being able to have like extensions to Express-paymail. So if you create a custom capability because, I don't know, you are testing stuff, or, well, you are basically taking advantage of the BRFC standard and you want to create your own capability that provide a way to plug in new capabilities into Express-paymail, like external capabilities.
Yeah.
But until now, it grows, it works, and it covers almost all the public payment spec.
Great.
Right. So should we move to the other one, to the client?
Sure.
Well, this is the client. Similar thing. It has like a cool README, which with a few examples. The payment is the client is kind of different. It's basically an object with a few useful methods to do stuff, like get an output, like a payment output for a specific payment, or get a public key here, get a public key for a specific payment, and it is taught to work with async await, so everything returns promises, basically. And that's basically the idea. Probably the only weird part that on the code that I plan to improve now that we know how, basically, is that it needs a few dependencies that are not like that explicit. You need to send the DNS and the fetch function. The fetch is a regular browser fetch. The reason why we did this is because of the DNS module. The DNS module is only present in Node, and it's not present in the browser. So the solution for that, which is half implemented in this, well, it's actually implemented in the new version, is use something called DOH, which is DNS over HTTPS. That is like a useful standard API to query DNS records using HTTPS. It was made by Google, I believe. And well, basically what we did was abstract the DNS and behind, like, well, use an abstraction. So in the browser we use that, and in the server we use the DNS module. But well, in the first version that wasn't ready, so that's why DNS is like an explicit dependency instead of being something implicit.
Yeah. So let me just add a bit of background just in case this is helpful to people. But just
yes.
briefly, Paymail is very dependent on DNS, which is basically like whenever you have like local part domain, you have to look up this SRV record for the domain to figure out where the Paymail is really hosted. So you have to do DNS queries, and DNS queries are a very low level internet protocol that you can access from a server easily, but you cannot easily access from a web browser because web browsers just don't give you access to those low level protocols. So there's actually no way to simply use DNS inside of a web browser. You have to use something like DNS over HTTPS inside of a web browser. So that's the complexity we're talking about here. It's like in order to use DNS and make it work both on a server and in a web browser, we have to worry about these things. And so that's why we allow it the ability to plug in a different DNS tool depending on a circumstance. But I'm pretty sure all this is now working automatically. Like I thought we had it working now where the Paymail library itself will handle DNS using DNS over HTTPS. I thought it was by default, but I'm not sure what the current situation is.
I don't remember. We can take a look. But if it's not doing that in this version, it's going to do that in the next version. We were really close to that. So, well, let's start by the payment client by itself. Yes, we have this code to actually do that automatically. That's true. So right now, if you don't send anything, it just works. If you don't provide like the explicit dependencies. But well, as I mentioned, basically it has a few async functions that are basically the other part of the capabilities that we just seen. Like, for example, what we did in Express-paymail was, for example, create an endpoint to deliver public keys for a specific payment. Here we have a method to actually get a public key, for example, get public key, right? So it's the same thing, but on the other side, it's how to consume what is on the server. And there are a few methods that basically consume a capability. For example, this one, get output for, or get public key for a specific payment. But there are a few other methods that are a little bit smarter. For example, is valid signature that actually check if a given signature is valid for a given message and for a specific payment. And that methods actually check, like, look if the server is able to handle certain capabilities and choose the right strategy to validate a signature according to the server set of capabilities. So it has a few things that like that are pretty useful to, again, to allow to remove the responsibility of thinking on the protocol for the programmer. Like, you can just use it and it works and it's going to do the best thing possible to actually check a signature, for example.
Yeah, if I could just pause on this one, just because I made a video about this stuff, and it's interesting to look at the source code now. So basically, yeah, if you could just look at the function name there and the description there. So
yes,
you know, in order to validate a paymail signature, you not only validate the signature against the public key, against the data like you normally would, but you also need to make sure that that paymail actually owns that public key. So what you're showing here in the source code is it does it one of two different ways, which is, first of all, if they have the verify public key owner capability, then that's the best way, which is you want to see basically, does this paymail have this public key? If they don't have that, you can do it the other way, which is you can actually get the current public key and see if that's the same. But that's slightly inferior because it doesn't let you ever rotate the key, basically. So it's just showing you in code this idea of validating a paymail signature means that normal signature validation plus confirming that that public key is actually owned by that paymail using paymail protocol. And so it's a convenient abstraction over all that stuff. You can just run this method and it does the correct thing, basically.
Exactly. So, well, yes, it's interesting that's true that you create a full video about this, and well, this is basically an implementation of that.
Yep.
There is a few other things that are kind of cool. Well, of course, there is a ton of test coverage about this. The payment client test file is actually pretty big because there is a ton of things to test. And there is a few things that I consider a good practice that I created here. For example, is here, yes. This object, the clock, this is just to have a nice test, and I believe that it was a right decision. Like, you might see there is a dependency that if it's not present, it creates a new clock and everything is fine. So usually you don't have to take care of that. But if you're going to look at the test, which I totally recommend if you have any doubt how it works, you're going to see that it actually uses a mock clock, which is an object which you can configure the current moment, basically. So every time that you need which moment is now in the code, instead of just access moment.js or JavaScript datetimes, it uses clock objects. And again, the idea of this is it's really easy to test the time if you can change the implementation of the clock. So that's something that might sound weird for some developers, but again, the idea of this is making really easy to test these kind of things. That without this, it's actually really hard to test the time. And the other things, again, I'm in the test, I use these lazy variables are extremely useful. And there is not so much about this. There is a few implementation, or there is a lot of code related to DNS because, as Ryan said, this is like critical to paymail. And in the client side is where we actually care of resolving the DNS, get the records, get the SRV records, and do stuff. So there is a lot of code related to us. There is a few, the other thing that is really important to Paymail is this standard called DNSSEC, which is the equivalent of HTTPS, but for DNS. It's like a secure way to query DNS. And well, again, handling DNSSEC has its issues because the standard DNS live module on Node doesn't handle DNSSEC. So in order to do that, again, we are using DOH, but DOH is super slow compared to the DNS module. So what we actually do is use the DNS module, and only when we need to verify DNSSEC, we use DOH. So there is a lot of, well, not a lot, but there is some code handling that logic. Well, again, that's probably the more like the weird part, the DNS handling. The other stuff are just regular code and HTTP request, and again, handling the protocol. And probably the difference with the other one is that there is no like in Express-paymail there was like all these handlers because you need to plug your proprietary code in the middle of the protocol. But in the client, you just use the client to get stuff. So it's like a regular library. It's easier. I believe that this is like easier for a programmer. It's just you create a client object, you send messages to it, and that's it.
Yeah. Yeah. Okay. Great.
Yes, I don't know if there is something else that you believe that should be clarified or some.
I guess
question.
I could add one more comment about the DNSSEC stuff. Yeah, let me just briefly talk about DNSSEC. So, you know, when the web was created in the early 90s, everything was unencrypted and unauthenticated. And they knew that, well, that's not very secure. Everyone can see everything you're sending around, and everyone can mess it up. If you have a computer in the middle, you can man in the middle attack everything. So they wanted to start adding cryptography. And one of the most successful protocols that was created was SSL, later renamed to TLS, which is basically secures most of the internet. The way this works is when you communicate with a website over HTTPS, it uses this protocol TLS, and it relies on a hierarchy of certificates. So there's a root certificate authority that signs off on a bunch of SSL people that are like lower level. So you have the top level sign off on these people here, which are businesses, and then they can sign off on your domain name. So you end up getting a public key that they sign off on. And contained inside every web browser is actually that hierarchy, that you actually have the root certificate authority and a bunch of keys from a bunch of these different providers, so you can validate that they've signed off on your key. And what this means is it's like this semi-trusted approach to basically finding a public key for a website and then being able to communicate privately and authentically with that website. And so that works for the web, but DNS is really a separate protocol. And later on, I mean, basically there are sort of edge cases in DNS where you need to worry about the same thing with DNS, where when you query what is the IP address for this domain name, there are opportunities for people to basically see what you're doing as well as man-in-the-middle attack you. And so a protocol called DNSSEC was created, which is just like HTTPS, but for DNS. And we've decided that basically in Paymail, we're going to enforce enforce DNSSEC in cases where there's a third-party hosted domain name. And it's depending on your domain name provider and all this stuff, it's usually pretty easy to set up DNSSEC, but it also is a bit cumbersome. So we only want to require it where it's actually actually necessary. And it turns out that there are cases where basically if you're at a coffee shop and you're querying someone's Paymail and they're hosting it a third party, meaning you get back something other than the primary domain, it is possible for someone else at that Wi-Fi Wi-Fi network to actually man-in-the-middle attack your connection, give you a different paymail provider, and then therefore result in like attacking you because you could send money to the wrong place. So we want to enforce DNSSEC in that case because it removes the possibility of there being any man-in-the-middle attack on that. So I believe I talked about this in one of my videos. I forget which one, but in any case, that's just ropes this in about what is DNSSEC and how it matters. And part of the way that we're enforcing it is actually to use the DNS over HTTPS.
Yes, just also like two additions. Like one is that we are actually enforcing DNSSEC at Money Button. If in that case, like if your payment API use the same domain as your payments, for example, you have, I don't know, I have an app called Miguel.com, and I have payments that are, I don't know, user@Miguel.com, and my API is actually hosted on HTTPS Miguel.com, that's okay. There we don't need to validate DNSSEC because the HTTPS is strong enough there. But if I delegate my payment API into a different domain, there is when, as Ryan said, we validate DNSSEC. And we need to do that because it's actually, there is a posture attack there. So if you are implementing paymail, please consider like you need to add DNSSEC in that case. It's not going to work, not only for us, for everyone using our library. And I hope that the other implementations also validate that because it's an important part of the payment protocol. Enforcing DNSSEC is part of the security of payment.
Okay, great. All right. Well, Miguel, is there anything else? I mean, this is a wonderful overview of the paymail source code. Anything else we should discuss with this?
I don't know. So the same thing, like next thing that we going to add to this code, I don't know when, but eventually are the same as Express-paymail, improving the cache, using the cache headers and stuff, and create a way to plug in external capabilities. Like if you create a custom capability, plug in the code on the client to actually consume your capability. That's something that would be really,
so people can expect, I mean, basically we work on this all the time. So, I mean, we're always improving stuff like this. So people can expect further updates in these paymail libraries. So if you are using them in a wallet project, I mean, be on the lookout for the updates because we're making it better regularly.
Completely.
So, yeah. Okay, great. All right. Well, Miguel, thank you very much for this wonderful overview. I hope this was helpful to the wallet developers. And as a reminder to the audience listening to this, what we're doing with Money Button is you probably don't have to actually worry about any of this. You can just use Money Button most of the time. But if you are building a actual wallet yourself, then we provide all the source code for you so that you can use a paymail inside of your wallet.
Which is really, really cool.
Yep. All right. Well, great to talk with you, Miguel. And I guess we'll sign off here. And thanks again for doing this wonderful overview.
Thanks to you.